So as you can see, Lagrangian method for first order, we got the current for 5 voltage is 4 milliampere, and for the second order we got 5.0125 milliampere. For the second method, named Newton's divider difference, first order we got 4 milliampere, and second order we got 4.0125 milliampere. Lagrange and Newton give the same result if using the same point, but Newton is more convenient for incremental calculation. That's all for the first question.
Next is for question 2. Compute the energy stored in the capacitor using energy formula, where P equal to VI by using two numerical methods. Compare your result from the different methods and conclude your findings. So for my calculation, I use two numerical methods, which is trapezoidal rule and Simpson's rule. So based on the table and information for the trapezoidal rule, from the information I got B is equal to 10, A equal to 0, and N is equal to 5. First thing first, I'm calculate the value of H, which is B minus A over N, and the value that I got for H is 2. Then I apply the formula for trapezoidal rule, and then I insert the value of B that I got from the table, which P is equal to VI just now, and the final answer for trapezoidal rule is 271 mJ. Next is Simpson rule. By using the same information and the same information from the table, I applied the formula for the Simpson's rule. Then I insert the same value, which is from B, A, and N, and then P from the table that I calculate just now. Then calculate it all, and I got the answer 223.6 mJ. To conclude, both trapezoidal and Simpson rule method have close similar approximation of the area. However, Simpson's rule method produced more accurate approximation, where it used parabolas to approximate the curve, while trapezoidal rule approximate the area using trapezoids, which is straight line segment.
So we move on to question 3. So from the question we list out the information, where R is equal to 10 kilo ohm, C equal to 100 times 10 negative 6, and H equal to 0.1. So first method that I will use is Euler method. The general formula is Y initial plus 1 equal to Y initial plus F xy times H. So I let it to be Vn plus 1 equal to Vn plus Ftv times H to prevent confusion. So we start to derive the formula from the equation, and we get that dV over dt is equal to negative V, and then we subs into the equation, and we got Vn plus 1 is equal to 0.9 Vn. So when step size is equal to 0.1, to reach 1 second that the question we need to do 10 steps. So the new equation that we will use is 0.9 power of 10 times V initial. So we substitute the value of V initial, and we get 3.487 for Euler method. So next method, Hund's method. The general formula is Vn plus 1 is equal to Vn plus F Tn plus 1 over 2 Vn plus 1 over 2 times H. We list out the information, and first step is we need to find the midpoint here. So for the first step, I is equal to 0, and then for the T 0 plus 1 over 2, we get a 0.05. V0 plus 1 over 2, using the formula, we got 9.5. So from here, we know that the FTV is equal to negative 9.5. And then first step, for this method, we got V1 is equal to 9.05. This also need to do 9 more. We need to repeat this step 9 more times because the number of step is similar to the previous method. So this is my second step, third, fourth, 5, and until 10. So 10, we can get the V on 1 second, which is from this method I got 3.70 at 1. So from the value that I get from the 10 step, all 10 step I already tabulate, so easier to check. And then now what we need to do before we compare between both method is we need to find the error over the initial value. So first we need to derive the equation to find the initial value for V on 1 second. So we got 3.68, and then the percentage for Euler is 5.2%, and Hyun method we got 0.8%. So from both error, we know that the Hyun method has less percentage error than Euler. That means Hyun's method is more accurate. That's